Well, we've been asked to solve the inequality x squared plus 5x minus 24 strictly negative. Basically, we've been asked to find or to study the sign of x squared minus plus 5x minus 24. Okay. So to study the sign, the first thing we have to do when we have this polynomial of second degree is to identify the root. To identify the root, we set that polynomial equals 0. And we look for the value of x that set that polynomial to 0. Okay. In general, a polynomial of second degree is in as the following expression: a times x squared plus b times x plus c equals 0, where a, b, c are constants. And then we compute what's called the discriminant. Discriminant we call delta. Delta equal b squared minus 4 times ac. Okay. If delta is negative, there's no real solution. Okay. If delta equals 0, there's one solution. Actually, it's a double solution. X1 equal minus b divided by 2a. If delta is positive, the two distinct solution, two distinct real solution. X1 equal minus b plus square root of delta over 2a, and then x2 equal minus b minus square root of delta divided by 2a. Okay. Now we're going to apply this technique of discriminant to our polynomial of second degree at hand here. X squared plus 5x minus 12 equals 0. So delta equals going to be b squared is going to be 5 squared minus 4 times AC is 1, C equal minus 24, this is equal 121 or 11 squared. And therefore, the root are x1, since this is a strictly positive. So we have two distinct roots. The root are x1 equal minus b minus 5 plus square root of delta plus 11 divided by 2 divided by 2 equal 3. And then x2 equal minus b minus 5 minus square root of delta, which is minus 11 divided by q divided by 2 equal minus 8. So if we draw the line of the real numbers, x, so we draw the line here, x move from infinity to plus infinity, and 0 in the middle, the root minus 8 is on the left, and plus 3 is on the right. So we need to find the sign of this second degree polynomial for all value between minus 8 and 3, and all value greater than 3, and all value smaller than minus 8. Now, let's start with all value between minus 8 and 3. To find the sign of polynomial here, all we need is to pick one value and plug in the expression of polynomial to see what sign is here. The most obvious value to try is 0. If we plug 0 to s squared plus 5s minus 24, the answer you get is minus 24 is negative. So for all value of x between minus 8 and 3, the polynomial is negative, minus. Now, for all value greater than 3, we pick one example, let's say 4. If we plug 4 here, so it's going to have 16 plus 20 is going to be minus 24. So 16 plus 20, 16 plus 20 is going to be 36 minus 20 is positive. So it's positive. Here to study the sign, you will plug one value. Example with minus 9, we plug here. Minus 9 squared is going to be 81. And then here is going to be minus 45 minus 24. So 45, 20 minus 40. 5 minus 24 is going to be minus 69. Minus 69 plus 81 is positive. Okay. So the polynomial is going to be positive for all values smaller than minus 8, and for all value greater than 3, and negative for all value strictly between minus 8 and 3. So the solution of this inequality that we've been asked to solve is going to be x belongs to the open interval minus 8, 3, which is equivalent is strictly between minus 8 and 3. That's it.